Want to grind some rails in Unity? Well, I decided to make a tutorial for it because I figured out how to do it, and I couldn't really find any tutorials on it, so here we go. I should start off by saying that this is just one way of doing it. It might not necessarily be the best way of doing it. But if you think it can be improved, feel free to get in touch and leave a comment, and let me know. How this is going to work is I'm going to run you through each of the scripts, and what this should be attached to, and how they all work. Let's get started. Okay, so here's the basic scene setup. I've got a player, a ground, and a spline. I also have the cinemachine and camera. So the packages I've got the spline package, of course. I've got the Unity input system, that's the new input system. And I have cinemachine for the camera stuff. My character is just a basic character controller with a just basic movement script, as well as a player grind script, which we will get to in a moment. The spline is a spline with a spline extrude on it, a mesh collider, and my custom rail script, which I will get to in a moment. So, just to give you an example of what is going to happen when we are done here, I'll give to you an example of how it works. I get on the spline, it follows the spline, and I can go in either direction. And I can get on at arbitrary points, and it still follows the spline. Very basic, but works. Okay, so let's start with the rail script here. Right, so in the rail script I have 3 public variables. The first one is labeled normal direction. It's not actually a normal direction, I just couldn't think of a better name for it, but it basically dictates which direction you're going down the spline. So in normalized time, a 0 to 1 or a 1 to 0, you get what I mean. It means if you're going one way or you're going the other way. I have a spline container called rail spline, and a float called total spline length. And then I get the components in the start method here, and the total spline length is the rail spline.calculate length. I have several methods. The first 2 are local to world conversion and a world to local conversion. I will explain why you need these in a little bit, but it's very basic stuff. It just transforms the local point into a world point, or transfers the world point into a local point. The last 2 methods here. Calculate target rail point. What this does is takes in the player's position and outputs a normalized time, but it also outputs a world position on spline, which is where the player moves to. This is using spline utility, which takes in the spline, the local position of the player, so I convert the world position into a local position, and then it gives a local position of the nearest point and the normalized time on the spline. So it gives you the position on the spline where the player would be, and it gives you the time on that spline. I then convert the world position to the nearest point and return the normalized time. Calculate direction. What this does is it compares the rail forward, or rather the forward from the rail, and then the player's forward. It then calculates the angle between the rail forward and the player's forward normalized. So what this is doing is it's comparing the forward of the tangent from the spline evaluate method and the player's forward normalized. And it sees how large the angle is between where the player is looking towards and where the rail is going. And if the angle is greater than 90 degrees, it means they're going in the opposite direction of where the rail wants to go. So in terms of like 0 to 1 normalized time, it's not going from 0 to 1, it's going in the opposite direction, it's going from 1 to 0. And I simply set the direction, normal direction boolean here to either false or true. So if it's greater than 90, that means they're going in the opposite direction, so I set it to false. If it's less than 90, that means they're going down the rail, so it's true. Okay, moving on to the grind script that's on the player grind script. I have two inputs, I have a jump and my general input. Jump isn't used here, that's if you want to jump between rails, you can just set that, but I won't be showing you how to do that in this video. Input is just... It's also used for that, so you don't necessarily need this, but you may do if you want to have jumping between rails. I have a bool that's called onRail that just determines whether or not you're on or off a rail. I have grind speed. I have height offset. This determines... So when you're grinding the rail, if you don't have a height offset, it's going to set your position to be more or less inside the rail. So this height offset just makes the player a little... just moves the player up a bit, so that they actually look like they're on the rail rather than the rail being inside them. Time for full spline, that's the total time it would take to traverse the whole spline from end to end. Elapsed time, that's how much time has elapsed from the beginning of the spline to where the player is. And then there's lerp speed, which is used for the rotational stuff. As for the scripts, I have the current rail script, and although I use the character controller, you can also just use a rigid body if you want to set that up. I don't have that here, so don't worry about it. I also don't really use the character controller code at all really for this tutorial, but you can implement extra stuff if you need to. Okay, so in fixed update I just have a single if statement. If on rail, move the player along the rail. But before we get to that, let's get to on controller collider hit. This would be on collider hit or on collider enter if you were using rigid body. So what it does is checks if you have hit a rail. On rail is true. It sets the rail script of that rail to the current rail script in player grind, and it calculates and sets rail position. That calculates where you're going to start when you move along the rail. So calculate and set rail position. So time for full spline, that is going to be your total spline length divided by your grind speed, and that will give you the total amount of time it will take for you to get from one point to the other. Vector free spline point, that's going to be the position we're going to start at when we move along the rail. Normalized time. So this is where calculate target rail point comes into play. As you can see, that's going to give us a normalized time as well as the nearest point that we will convert into a world position. So it spits out spline point, which is our world point, and then elapsed time is the time for full spline multiplied by normalized time. That will give us because normalized time is between 0 and 1, this will calculate the amount of time that has elapsed. So for example, if your spline takes 5 seconds to traverse but your normalized time is 0.5, it will start you at 2.5 in terms of elapsed time. Float free for position, forward and up. Forward is tangent, by the way. So for spline.evaluate, it says here there's out for position, out for tangent, and out for up vector. Forward is tangent. Float free operates more or less the same way a vector free does. They are basically interchangeable, so don't worry about that. But spline utility dot evaluate, that takes in the spline, that takes in your normalized time, and it gives you a local position, your forward, and an up vector. We are going to use that forward to calculate direction, so remember, calculate direction takes the forward of where the player is on the rail and the player's actual forward, and then compares them to an angle, and then it sets the player's position to be the spline point plus transform.up times the height offset. So that just adds the height offset to their position so that they are not, going through the rail, they're like on top of it. But depending on how you have that set up, you may not need that. So once that's done, and we're in our move player along rail phase, let's look at that code. So this first if statement is more or less just a bit of extra error checking. You may not need it, you might need it. I'm leaving it in for the time being. So the first thing we're calculating is progress. This is elapsed time divided by the time for the full spline. This will give us a normalized time of between 0 and 1, with 1 being 100% and 0 being 0. I then do a progress check. So if progress is less than 0, that means it's before the start of the rail, or progress is greater than 1, which means it's after the end of the rail. We have a throw off rail method, and then it returns, which means that none of the rest of the script gets used. Let's say progress isn't less than 0 or greater than 1. I have a float for next time normalized, and we're going to use this to calculate the forward. I'll explain why I'm doing that in a moment. For how that is calculated, I look at which direction the player is going, and depending on that, I simply add time.delta time to elapsed time and divide it by the time for full spline, which gives us basically progress again, but next progress, or rather the progress for the next frame. Likewise, if the player is going backwards up the spline or going in the other direction, instead of adding it, I subtract it. And then I have two float free sets here. I have one for the current position, and then one for our next position. So position tangent, which is also a forward, and up. And then I do spline utility.evaluate, and that will give us the current position, forward, or tangent, and up. And then give us our next position, tangent, and up. And then I convert both of those positions into world space. So first thing I do is I set the position to the world position plus transform.up multiplied by height offset. Again, that just sets you a little bit above the rail. Now, this first transform.rotation change is for the forward. So I use a lerp, and it's transform.rotation, and then look rotation, and I have the next position minus the world position. This basically will set our forward to the direction between where we're at and where we're going. So the reason I'm doing that is if I use the tangent for where we are, it's fine if we're going down the rail, but if we go in the opposite direction, it breaks. So that's why I am doing it like this. As for the next rotation change, this is for the up vector. So it's from rotation to rotation. That's transform.up to our up from where we are on the spline. We don't really use our next up at all. So we just use our current up, and then we multiply that by transform.rotation. And that makes sure that we're upright following the spline correctly. Once that's set, I then do elapsed time plus equals time.delta time, so that increases our elapsed time so that when we get back to this, when we get back to calculating our progress for the next frame, it will be correct. It'll be, incremented for the next frame, and then we do the calculation again. Likewise, if you're going backwards, it's minus equals time dot delta time. So, when progress is less than 0 or greater than 1, we have a throw off rail here, and that's fairly simple. Throw off rail, you set on rail to false, you set the current rail script to null, and then what I do is I set the transform.position to plus equals transform.forward and then 1 unit. And that just sets them a little bit ahead from where they are facing. So when they leave the rail, they're facing in a certain direction, so I just put them 1 unit ahead in the direction they're facing, and they're off the rail, and it's fine. It's a little jittery, but it works for the most part. You could maybe lerp it or do whatever you want to do there. I don't know, set it as set like a coroutine here to set that position, but for our purposes, it works fine. And that's the whole script. Just to show you again, the player gets into contact with the rail. It sets on rail to on, or on rail to true. It calculates where on the spline they're going to be. Then when they're on the spline, it calculates their forward and their up, based on their position and their next position. And then once they reach the end, they're moved 1 unit forwards, and they're off the rail. And you can continue on as you were. And just to prove to you that it does work with other rails, I'm going to make another spline. Just as a quick note, make sure you have your tag set for the rail and layer on rail as well. I've set them up here, you may wish to do the same, but definitely do the tag, because otherwise this system will not work for you. Right, so that's our rail setup. I will now demonstrate that it works. So I just hop on it. There you go. That proves that it works. I can get on it on either direction. And it works fairly smoothly. And there you go. Hopefully this video has been helpful to you. Let me know if you use it in your game. These files will be available on GitHub. The link will be in the description. If you like what I do and are interested in seeing more, feel free to subscribe. I also stream on Twitch, links in the description. And I'll see you guys next time.